The discharge in soakaway, water is discharged into a soakaway or a leaching field as it's sometimes called, which basically consists of meters of pipe. You can see some examples of the pipe here. So it's perforated pipe, so it's a pipe with holes in it, and this is basically led under the soil, and that basically is, the function of that is to perforate or to evenly discharge the waste effluent from the septic tank into the ground. And it allows the wastewater to drain away efficiently over a sizable area, and the soil type needs to be also considered. That actually allows the liquid to soak away and to drain away. For that reason, because you need a sizable area and you need to also be careful of the type of soil, the siting of a septic tank in heavy clay soil may not be suitable. So you need to have a soil that will allow the effluent to drain away. Free draining sand and gravel tend to offer the best conditions for the siting of a septic tank. The discharge in the soakaway, the fall of distribution drains from the outlet should be as shallow as possible, and normally it'll have a 100 to 200 to allow slow percolation, so you don't have a high drop in your drainage or your soakaway. The bottom of the trench of the perforated pipe should be 900 millimeters above the seasonably high water table or bedrock if possible. So it needs to be that's the 900 millimeters away from the high water table. If the water table is closer to the surface than 900 millimeters, then it may be possible to run the soakaway drain closer to the surface, but you need to ensure that the water does not come up to ground level. A discharge soakaway, again, the trench in which the discharge perforated pipes run can be backfilled with aggregate, basically sort of broken down rocks, to assist in the percolation of the effluent into the ground, and that aggregate can be laid inside a wrap of geotextile material to impede the silting up of the soakaway with silt from the surrounding trench. So there's a number of different technologies and methods for basically constructing a soakaway. So you can see these septic tanks with soakaway crates that allow for a good soakaway that has a good aggregate and a good drainage characteristics. Soakaway drains should be long enough to allow the water to percolate into the subsoil, so you don't want to see the effluent from your septic tank coming to the surface. And a typical evaluation of the permeability of the soil will include a percolation test to see how quickly liquid will disperse into the soil. Clay soils will obviously be less absorbent than coarser, sandier soils. Just a few final notes. A soakaway should not be constructed where the groundwater table is close to the surface. In fine soil, the penetration distance of bacteria may be around 3 meters from the soakaway, and coarser soils will enable greater penetration. Limestone substrata will most probably be fissured, or in other words it'll be cracked, which enables septic tank effluent to flow away too freely into the water table below. So generally a septic tank in a limestone substrata is not allowed. Coliforms, basically gut bacteria, reportedly can survive for as much as a month if they reach a source of groundwater. So you run the risk of contaminating the groundwater source if the effluent from your septic tank runs straight into the groundwater source. Boggy or peaty ground is also not really suitable for septic tanks because the percolation rate is very, very slow, and it's almost inevitable that the soakaway will eventually clog. So it's also worth positioning the tank and soakaway so that alternative soakaway drains can be excavated in future. So you need to always consider that the soakaway from a septic tank will clog up, so you need to have position it in a position where you can always put a new one in. Also, if you do find it clogging up, some companies do offer different solutions and novel solutions. This company here, for example, Soakaway Worms, sells buckets of worms that you can put in your soakaway that will help improve the drainage of your soakaway. And BRE Digest 151 on soakaways details the requirements for the construction and sizing of soakaways. To size a septic tank for a domestic property, it basically depends on the quantity of liquid that's being discharged to it, which in turn is dependent on the number of people in the dwelling. So, taking the sizing requirements from the British Standard BS 6297 for small domestic sewage treatment works and cesspools, the septic tank capacity is calculated by the following equation. The capacity that you select is, or the capacity that you will specify is given by the number of residents multiplied by 0.14 and plus 0.18. So for a house with 4 occupants, the capacity is given as 4 times 0.14 plus 1.8. So you basically need a capacity of 2.36 metres cubed of a septic tank. And 2.36 metres cubed is equivalent to a capacity of 2,360 litres. Positioning the septic tank, it must be at least 7 metres away from any habitable part of the building, and preferably on a down slope from the building if there's a slope on the property. And within 30 metres of suitable tanker access for the annual emptying of the septic tank. A drainage field or mound serving the septic tank must be at least 15 metres away from the building and 10 metres away from any watercourse, permeable drain or soakaway. The drainage field may not be covered by any drives or roads or paved areas as well. Steep sloping sites should be avoided where possible, and sites should also be remote from ditches, streams and wells. So basically you have to take precautions just to ensure that there's no opportunity for the effluent of your septic tank to get into any waterways. In cases where a septic tank cannot be installed because it is close to a waterway or drain or something, then the other alternative is a cesspit. And basically a cesspit is a sealed storage tank into which the sewage is drained and is held in the cesspit until it is removed. Sewage is, unlike a septic tank, the sewage within the cesspit is not treated in the tank, it's just stored until it's removed. In some areas where the septic tank is not suitable, such as there's no suitable drainage in the subsoil, or it's close to water drains, or close to the water table, then a cesspool is the only answer that you can do. Older cesspits tend to be cylindrical pits lined with brick or concrete, but modern cesspits tend to be made from fiberglass steel or polyethylene and would have a sort of a structure as shown in the top picture here. Current building regulations require cesspits to be able to hold at least 18,000 litres of sewage, and it's estimated that each person will produce 115 litres of sewage per day. So for a family of 4, that means that you get at least about a month's worth of storage of sewage in a cesspit. So basically the cesspit will have to be emptied every month. And that basically concludes an introduction to septic tanks and cesspits for below ground drainage.